In this presentation we are looking at conditional probability. So essentially what I'm going to do here is just introduce a bit of notation and also how to use Venn diagrams to help visualize this. So consider two events A and B such that the probability of A equals 0.3 and the probability of A intersection B is 0.1. So find the minimum and maximum possible values of the conditional probability A given B. Okay, so what I have done here is I've sort of started this off in a previous version of this video. So essentially what we have to do here is to sort of be mindful of the notation, because you're going to sort of see this notation quite a bit. So the intersection symbol is what we're using in the question. That also corresponds to the state of being and something, A and B, as in it has to be both. So that looks like an upside down U or an N without the top corner tail. Okay. The other one is the union symbol, and we're not using that here, but it's good to see both together. That corresponds to the logical state of or the state of being A or B. I shouldn't call it a logical state, but it pops up in logic. All right. Okay. So this is the formula for conditional probability, and this is going to be a big part of your statistical learning, your statistical life. Probability of A given B equals the probability of A intersection B over the probability of B. Or you can just say probability of A and B over the probability of B. Okay. Now, so what I'm going to do here is I've actually discussed how to do this, but it's actually best to visualize with Venn diagrams. Okay, so this is a Venn diagram, and this describes every possible outcome. Okay, the entirety of the sample space. So the area that is encapsulated by that rectangle, that red rectangle, is 1.00. Okay, now this is the event A, which is the collection of sample points that inside that circle. And we would describe that as the probability is an area of being inside that circle. Likewise, B over here. Okay. Now, we know that the probability of A is 0.3. Okay. We're also told that the probability of A and B is 0.1. Okay. So that 0.1 there, 0.1 here sort of describes this region here that it's in. Okay. So if the entirety of what's inside A is 0.3 and this area here that's in both A and B is 0.1, what means that what is left here is 0.2. Okay. Now altogether we have two possible options as to where everything else is. So what's outside of A is 0.7, but it has to go somewhere. Okay. So what we're interested in really is what is the area encapsulated by B, which is this area here, including the intersection. Okay. So there's two possible scenarios. Let's say for argument's sake that there's one scenario is that the entirety of the 0.7, there are two possible extremes, actually, I should say. They're not scenarios. There's multiple scenarios. But one extreme and the other extreme are what we're being asked. So this is one extreme, which is to say that the extreme that minimizes what is in B, what is contained in B. Okay. Now we know that this 0.1 here is contained in B, but let's just say under this scenario, this extreme, that there's nothing else outside of that. Okay, so in this scenario, the probability of B equals 0.1, which is to say there's 0 here. Okay, the area here is 0. So that is this would be the minimum. Okay, so the other possible outcome is, I just cloned that there for a second. I'll just start this again. 0.2 here, 0.1 here. Now the other possible scenario is that the entirety of what is left over is entirely within B. This is the other extreme. So in this case, B, the probability of B is the 0.1 here and this 0.7 here, which is 0.8. So the probability of B in this scenario, this is the scenario that maximizes B, and that scenario is a probability that probability is 0.8. So essentially what we have here is our two possible values there. So I'm just going to sort of rub some of this stuff out. The maximum possible value of PB is 0.8, which in this case is probability of A given B equals 0.1 divided by 0.8, which is 0.125. That is to say that 1/8 of B is also in A. Okay. The minimum possible value of PB is 0.1, which is to say B is a subset of A, and in that case the probability of A given B is 1. Okay, you can work that out the same way. That would be 0.1 over 0.1, which would give you 1 if you use that formula there. Okay, so this is why Venn diagrams are very useful, because they help you sort of rationalize a lot of, sorry, that is the conditional probability formula just I was pointing to up there. I think it was just a little bit out of shot. But this Venn diagrams can help you rationalize and simplify a lot of expressions. Okay, we'll leave it there.